Welcome to Anatomy Coloring Book, page 97. This is Dr. Stephen Harkins. The auditory and vestibular systems. Vestibular meaning balance and keeping you upright, keeping you from sort of falling over. So auditory, of course, meaning hearing. So both of these systems are located in the same place. And let's start by talking about the external ear. Outwardly, we have the auricle. This is what we commonly know and see as the ear. It's the sort of fleshy part down here and the cartilage up here. And so that's the auricle. The canal leading into the middle ear is called the external auditory meatus. This is the external auditory meatus. The sound comes in, the sound waves come in from this way, and they're sort of channeled through the ear and into the external auditory meatus. Sound travels down to this little thin membrane right here. It's actually a piece of skin, a very thin, clear piece of skin called the tympanic membrane. Tympanic as in drum, and a membrane, as I said, is in kind of a thin sheet. And so here is the tympanic membrane right here, with the sound energy traveling through the external auditory meatus there. Of course, the sound vibrates, it shakes the tympanic membrane like a drum, like the head of a drum. And connected on the other side of the tympanic membrane are three tiny little bones with synovial joints in between them. So they're little joints, bones with joints. One is the malleus, because it looks like a hammer. The next one is the incus. It looks like an anvil, supposedly. And the next one is the stapes, which is supposed to look like a stirrup. And that, of all the bones, looks like what it actually is supposed to, like its name, the stirrup. Okay, and so these three bones take the sound, they communicate the sounds. The vibrates hit the tympanic membrane like a drum, and then the sound is vibrated through these three joints here, these three bones with joints. And here again is the malleus. Here, the hammer. And there's a little joint there, a synovial joint between it and the incus, the anvil. You see the little expressions around them, meaning they're moving, they're vibrating. And then the stapes, the stirrup. Funny looking little bones right here. And so these bones, as you can see, they're vibrating from the taking the vibrations from the tympanic membrane, transmitting them through the bone. To their next stop, which is the transmitting the sound to the vestibule of the cochlear area, or the bony labyrinth of the middle ear. Here, transmitting into this area I called the vestibule. And from there, that sound energy will be turned, that mechanical energy will be turned into an impulse, a nerve impulse, to be interpreted by the brain. There's a little canal off of the middle ear. By the way, the Inca, or the Malleus, Incus, and Stapes were in the middle ear. The external ear is this with the external auditory meatus. Once you get on the other side of the tympanic membrane, though, it's the area called the middle ear. So the Malleus, Incus, and Stapes are in the middle ear. And then coming off the middle ear, so this whole area here is the middle ear with the three bones on the other side of the tympanic membrane. And this little tube here is called the auditory tube. It drains, or the eustachian tube. It drains into your nasopharynx area, into your mouth area, in your mouth and nose area. Your pharynx into the back of the throat. That's the auditory tube. Also, when you yawn and you feel that popping in your ear, what's happening here is sometimes this tube gets closed off and it gets stuffy. But when you yawn, you might be opening this tube. You're opening this tube here, and it allows the pressure, the air from outside. See, when the tube gets cut off, now there's a certain amount of pressure inside the middle ear. And when you open up that tube, the pressure equalizes as the air from the outside, from where your mouth is, gets to come on in and be the same, to equalize the pressure from outside your body to inside the middle ear. So that may mean that air either travels out or goes into the tube or into the middle ear, just so the pressure inside the middle ear is equal to the air pressure outside. And that's what's meant by equalizing pressure. And of course, this diagram up here is a blown up of what's going on inside the middle ear. Now, the internal ear, there is a bony labyrinth. In other words, think of a cave sort of carved out of the bone in your ear. And this cave has many passageways and loops and paths, and what's carved out of the ear, as you can see here. And then there are these membranes that sort of inside the ear that sort of match the pattern and path of the ear, of the bony labyrinth. So the bony labyrinth, and the first meeting point in the bony labyrinth is this open area in the middle called the vestibule. And that is the it's the contact point for the stapes. This contact point right here, I actually made it red right here. It's the contact point right here for the stapes. It's an open area here that connects to these semicircular canals and this cochlea here. And we'll show you that right now. So on the vestibule, it's this open area here, is this oval window. And here's the vestibule, sort of whole open area here, right in the middle, in between the vestibular structures and the auditory structures, the balance structures and the hearing structures. Remember, there's two things that are happening, hearing and balance. So this is called the vestibule's in red here, and the oval window we'll put in red as well. And that's the area right here where the stapes, the stirrup bone of the ear, the third bone, transmits its vibrations into this sort of hollowed out area called the oval window. And as I said, it's an area that's carved out of bone. And so the first area that's carved out of the bone is the semicircular canal. That's these canals right here. Semicircular canals, carved out of bone. Right in this area here, carved out, okay? Here's your semicircular canals. Here's another one. They're in three planes, 90 degrees from each other. These semicircular canals are. there's a sort of superior, lateral, and a posterior canal. And they're going to become very important in balance, as we will show you a little bit in this lesson and certainly in the next lesson. The next bony structure carved out of the temporal bone of the skull is this area here, and that's called the cochlea. And the cochlea is where the hearing takes place, not balance, but hearing. So this is your cochlea here. It looks like a snail. And as I said, it's carved out of the bone in your skull, temporal bone in your skull. That's the cochlea. There are 3 passages in the cochlea. The scala vestibuli here, it's this pathway here, a hollow tube, or it's actually filled with fluid, and the scala tympani here. Also filled with fluid. And the third is the cochlear duct. The cochlear duct. This is where the hearing, the sensation of hearing occurs. Where the actual organ of hearing occurs. And it is called the organ of Corti, or organ of Corti. Here we go. It's right in here. This little organ, exploded out here, looks like this. And by the way, that's this diagram here was exploded from this little area right here. So this organ of Corti is wrapped. It runs through the cochlear duct and it wraps all the way around. So this is happening in a spiraling fashion, in this snail-like fashion, all through the cochlea. So sound is transmitted, and let's erase a little bit here. Sound is transmitted from the, let's see, as we know, in through the auricle of the ear, in through the external auditory meatus, onto the tympanic membrane, through the malleus, incus, and stapes, onto the oval window right here. The oval window of the vestibule, which is right here, onto the oval window. And in the vestibule, there's fluid. There's fluid in the vestibule. And the fluid starts to vibrate as well from the vibrations on the oval window from the stapes. In the oval window and the vestibule, when the sound vibrates, the fluid vibrates the fluid in the scala vestibuli. So this fluid here starts to vibrate, keeps vibrating and vibrating here, all the way around to the scala tympani. Scala tympani. Oops. And back, like so, and like so. Oh, scala tympani. Why don't I use a separate color? And there we go, to the scala tympani now. Let's see. Anyway, like so, all the way out till the point where it's dampened by this little window called the round window. So you can see that the vibrations from the stapes to the oval window are transmitted through the vestibule. You'll hear the fluids in the vestibule, and then around and around and around in this cochlea, in this snail-like maze. And what winds up occurring there is, in the process, what's picking up the vibration the whole time is the organ that's in the middle, the organ of Corti. Oops. So let's go back and see. Let's do a better drawing. So the sound waves were going to come into the scala vestibuli and then travel through the scala tympani, and all the while, these vibrations of this fluid happening in these two places are vibrating the cochlear duct because they're next to it. It's causing this wall to vibrate here and this wall to vibrate. So the cochlear duct winds up vibrating, which means the organ of Corti here, this red organ right here, winds up vibrating this organ from the vibrations in the two canals that are next to it, in the two scala vestibuli and scala tympani. Let's see if we can do a better drawing. So sound travels from the oval window, from the stapes, into the scala vestibuli here. And this section's been cut out all the way around, actually 2.5 times. Now in the scala tympani. All the way out and around. And this section's been cut off here, so we're just going to skip it. And out through the oval window where it's finally dampened at the oval window. In the meantime, this the cochlear duct has been picking up on all those vibrations. And the organ inside the cochlear duct has been sensing those vibrations, and we'll show you how that happens. The cochlear duct here, and the little organ inside the cochlear duct called the organ of Corti. Let's make it yellow. Organ of Corti. As those vibrations were passing by in the scala vestibuli and scala tympani, it was vibrating the cochlear duct as well. In particular, it was vibrating the tectorial membrane right here. Little membrane. It was vibrating a fibrous glycoprotein blanket, tectorial membrane. And when it was vibrating, here, let's put little vibration marks on it. And when that was happening, these little tiny little hair-like projections, hair cells on the organ of Corti, right here, were picking up on those vibrations of the tectorial membrane. And don't forget, the tectorial membrane runs along the cochlear duct, all along the duct here. So as long as these two areas are vibrating, the cochlear duct was vibrating as well, therefore the the tectorial membrane. So these hair cells were vibrating, and what winds up picking up that sensation, the other part of the hair cells, well, there's the little the little projections of hair from the cells. And these are the hair cells themselves, of course, with the nucleus in here. And contributing little nerves to the cochlear branch of the vestibulocochlear nerve. And you can see the impulses headed away to cranial nerve number 8, the vestibulocochlear. So we have our hair cells here. The rest are supporting cells. And this is cranial nerve number 8 here. Taking the information away. Here it is as well. Taking the signal, the sound signal, back to the brain for interpretation. Also contained in the labyrinth, in the bony labyrinth, is the semicircular ducts here. These are the vestibulars, the balance structures. And in the vestibule, by the way, there are these two areas called a saccule here and the utricle. Actually, it's vice versa. This is the utricle here, and this is the saccule here, contained within the vestibule. And these will become important when we learn about vestibular structures of balance in the next lesson. So a differentiation to note here in the internal ear, we're talking about the bony labyrinth and then the membranous labyrinth. The bony labyrinth is the area that's just carved out. And inside the labyrinth, there is a membranous area that matches the bony area in shape and size. And this has been page 97 of Anatomy Coloring Book. This is Dr. Stephen Harkins. The auditory and vestibular systems.